the limit no technology can outrun. For centuries, speed felt like a challenge, not a boundary. If something was too slow, you pushed harder. If it resisted, you added more power. Progress was defined by acceleration. Faster ships, faster signals, faster machines. It felt natural to assume that with enough ingenuity, any limit could eventually be broken, that speed was a temporary obstacle, not a permanent wall. Human history seemed to validate this optimism at every turn. Locomotives replaced horses, telegraphs replaced messengers, aircraft replaced ships, and each breakthrough suggested that technological advancement was unbounded. Every ceiling became a floor for the next generation. The pattern was so consistent that it shaped expectations about the future. Speed limits appeared as challenges to be conquered, not as fundamental constraints woven into the fabric of existence itself. To understand why this assumption still matters today, we need to return to the age of confidence, an era when technology consistently outran expectations. Each generation shattered the limits of the last. Barriers fell so reliably that limits began to feel imaginary. If nature imposed a ceiling, surely it was only because we had not reached it yet. The Industrial Revolution had transformed societies by overcoming limitation after limitation. Steam engines conquered distance. Electricity conquered darkness. Radio waves conquered isolation. Each victory reinforced a belief that human ingenuity could eventually solve any problem, overcome any obstacle, transcend any boundary. The notion of a truly permanent, insurmountable limit seemed almost superstitious, a relic of less enlightened times when people mistook ignorance for impossibility. This belief shaped everything. Engineering chased higher velocities. Communication aimed for instant delivery. Physics assumed that motion could always be increased with enough energy. Speed was treated as negotiable. Engineers designed faster vehicles. Physicists built more powerful accelerators. And inventors imagined ever more ambitious methods of propulsion. The underlying assumption was always the same. With sufficient resources, creativity, and determination, any speed could be achieved. This was not mere arrogance, but rational extrapolation from consistent experience. After all, every previous generation had faced limits that seemed absolute until they were broken. Why should the future be any different? But hidden inside the equations was a quiet warning, a number that kept appearing, a value that refused to change no matter how it was measured. Light did not speed up when chased. It did not slow down when fled from. It simply stayed the same. This peculiar constancy was noticed, but not immediately understood. When measured from a moving platform, light should appear faster or slower, depending on the direction of motion, just as sound does. Yet experiments revealed something bizarre. Light speed remained identical regardless of the observer's motion. This was not a small discrepancy that could be attributed to measurement error. It was a stark, reproducible phenomenon that defied common sense and challenged a framework through which motion had always been understood. At first, this was dismissed as coincidence, or error, or incomplete understanding. Surely nature would not enforce an absolute speed. That would imply a hard limit built into reality itself. Scientists proposed various explanations to preserve the familiar view of motion. Perhaps there was an invisible medium through which light traveled, and the measurement devices were somehow affected by motion through this medium in ways that masked expected variations. Perhaps the experiments were subtly flawed, missing some crucial factor that would restore the expected behavior. The possibility that light speed was genuinely invariant seemed too radical, too disruptive to the entire edifice of physics to be taken seriously without exhausting all other options. Yet every experiment returned the same result. No matter the motion of the observer, no matter the source, no matter the method, the speed of light remained fixed. Increasingly sophisticated experiments eliminated potential sources of error one by one. Different experimental designs, different measurement techniques, different conditions, all yielded the same conclusion. The constancy of light speed was not an artifact of limited precision or experimental bias. It was a genuine feature of nature, undeniable and unyielding. This repeatability forced physicists to confront the possibility that their fundamental assumptions about space, time, and motion might be wrong. This was not just a problem for optics. It was a threat to the idea of unlimited progress. Because if one speed could not be exceeded, then nature was not infinitely flexible. It was constrained. The implications extended far beyond behavior of light. If the universe imposed an absolute speed limit, then the entire trajectory of technological advancement might encounter a wall that no amount of ingenuity could breach. This challenged deeply held beliefs about human potential and the nature of progress itself. It suggested that the universe was not an infinite playground where any achievement was possible given enough time and effort, but rather a structured system with inherent boundaries that could never be crossed. And once that possibility was taken seriously, a disturbing question emerged. What if this was not a technical limitation at all? What if the universe itself had drawn a line that nothing could cross? This question shifted the entire framing of the problem. Technical limitations can be overcome with better engineering, new materials, or more sophisticated designs. But if the limitation was written into the fundamental structure of reality itself, into the very geometry of space and time, then no technological advancement would ever circumvent it. The limit would be as permanent and immutable as existence itself. That line would soon reveal itself not as an inconvenience, but as a structural feature of reality, one that no technology, no matter how advanced, would ever outrun. The recognition that this was not merely a practical barrier, but a fundamental property of the universe transformed how physicists understood motion, causality, and the nature of physical law itself. At first, physicists tried to treat the limit as a practical issue, not a fundamental one. Maybe engines were inefficient. Maybe materials failed. Maybe better designs would eventually push past it. History encouraged that optimism. Every previous limit had fallen. When steam engines first appeared, critics claimed trains could never exceed certain speeds without causing physical harm to passengers. When aircraft were developed, skeptics doubted they could break the sound barrier without disintegrating. Yet both barriers fell as technology advanced. This historical pattern created powerful expectations. Why should this limit be any different? Perhaps it simply required a more radical approach to propulsion, some breakthrough in energy generation or material science that would finally allow the barrier to be crossed. But this one behaved differently. Adding more energy did not increase speed. It changed everything else instead. Time slowed, lengths contracted, mass effectively increased. Motion resisted acceleration in ways no mechanism could overcome. As objects approached the speed limit, pumping in more energy produced diminishing returns and velocity gains. Instead of speeding up proportionally, objects became more resistant to further acceleration. Their inertia effectively increased, requiring ever more enormous amount of energy for ever smaller increases in speed. Stranger still, their measurements of time and space began to deviate from those of slower observers. Moving clocks ran slow. Moving objects contracted along their direction of motion. These were not mechanical effects, but transformations of space and time themselves. This was not mechanical resistance. It was geometric. The structure of space and time themselves pushed back. The universe was not saying no because of friction or weakness. It was saying no because of consistency. The resistance came not from any material property or engineering constraint, but from a fundamental architecture of reality. Space and time were not separate, static backdrops against which motion occurred. They were dynamically interconnected, forming a unified structure that responded to motion in precise, mathematical ways. This structure imposed a speed limit not as an external constraint, but as an inherent property. Try to exceed it was like trying to make a triangle's angle sum to more than 180 degrees in flat space. Not difficult, but impossible, ruled out by geometry itself. The conflict deepened as this insight spread beyond light. Any object with mass faced the same barrier. As it approached the limit, energy poured in with diminishing returns. Speed flattened. Effort became futile. The closer you got, the harder reality pushed back. Particles accelerated and powerful machines approached, but never reached the limit, no matter how much energy was pumped into them. Cosmic rays, accelerated by the most energetic processes in the universe, also fell short. Even massless particles like photons traveled at exactly the speed, but could not exceed it. The limit was truly universal, applying to everything without exception. Nothing in the cosmos could outrun it, and nothing ever had. This revealed a profound shift. Speed was no longer a simple measure of motion. It was a boundary condition, a property woven into the fabric of existence. The universe enforced it not with force, but with structure. Speed had transformed from a practical variable into a fundamental constant that defined how reality operated. It set the maximum rate at which cause and effect could propagate, the fastest possible transmission of information or influence. This made it one of the most important numbers in all of physics, appearing in equations that described everything from electromagnetism to gravity to quantum mechanics. The speed limit was not peripheral but central, not an oddity but a foundation. Emotionally, this was difficult to accept. Limits are uncomfortable. They challenge narratives of endless improvement. They suggest ceilings where progress must change shape rather than continue upward. For a species that had defined itself through overcoming limitations, encountering a truly insurmountable boundary felt like defeat. It implied that some dreams, faster-than-light travel, instantaneous communication across cosmic distances, would remain forever beyond reach. This was psychologically jarring. It forced a reckoning with the reality that human ambition, while vast, operates within a universe that imposes non-negotiable constraints. Not every goal is achievable. Not every barrier is temporary. Yet physics showed that this limit was not arbitrary. It preserved cause and effect. It prevented paradoxes. It ensured that information traveled in an orderly way. Without it, reality would collapse into contradiction. The speed limit was not nature being cruel or stingy. It was nature being consistent. By capping how fast influences could propagate, the universe ensured that events maintained a coherent temporal order. Causes preceded effects. Signals traveled forward in time. History unfolded in a logical sequence. Without this limit, causality itself would break down, creating paradoxes where events could influence their own past, where timelines could loop back on themselves, where logical contradictions would become physical realities. The limit no technology could outrun was not holding progress back. It was holding reality together. This reframing transformed the speed limit from an obstacle into a necessity, from a frustration into a foundation. Without it, the universe would not be a lawful, predictable place, but a chaotic tangle of contradictions. The limit was not what prevented progress. It was what made progress meaningful by ensuring a stable, coherent reality within which progress could occur. The conflict reached its peak when physicists realized what breaking this limit would actually mean. Faster-than-light motion was not just about speed. It was about time. Surpass the limit, and cause could follow effect. Signals could arrive before they were sent. The universe would lose its sense of order. This was not speculation, but direct mathematical consequence. The equations that connected space, time, and motion revealed that exceeding the speed limit was equivalent to traveling backward in time. An object moving faster than light relative to one observer would appear to another observer to be moving backward in time. This would allow sending messages into the past, creating closed causal loops where effects preceded their causes. The logical paradoxes this would generate, objects preventing their own creation, information appearing from nowhere, would render reality fundamentally incoherent. This buildup revealed why the limit was so deeply enforced. It was not protecting technology from failure. It was protecting reality from contradiction. The speed limit acted like a governor on causality itself. By preventing anything from traveling faster than light, the universe ensured that temporal order remained consistent across all reference frames. Events that one observer saw as cause and effect would never appear in reverse order to another observer. Time's arrow pointed in the same direction for everyone, even if they disagreed about the exact timing. This preservation of causal structure was essential for making the universe comprehensible, for allowing laws to be formulated and predictions to be made. Every attempt to imagine bypassing it led to paradox. Messages sent into the past, effects without causes, histories that rewrote themselves. The equations did not merely resist these outcomes. They actively forbade them. Reality closed the door completely. Physicists explored every conceivable loophole, wormholes, warp drives, exotic matter configurations, and every case found that the universe's structure prevented their use for faster-than-light travel. Either the proposed mechanism violated known laws, or it required impossible conditions, or it introduced paradoxes that made itself contradictory. Nature had not left any gaps through which the speed limit could be circumvented. The prohibition was absolute and airtight. This forced a final reframing. Progress was not about going faster forever. It was about working within the limits that made consistency possible. Speed had a ceiling so that time could have direction. Information had a maximum rate so that events could be ordered. True progress meant understanding these constraints and working creatively within them rather than futilely battling against them. It meant recognizing that some boundaries exist not to frustrate ambition, but to enable everything else. The speed limit was one of those boundaries, a constraint that, far from limiting what was possible, actually defined the space of possibility itself. Emotionally, this was humbling. The universe was not an open road with infinite lanes. It was a carefully structured system where certain shortcuts were impossible. No matter how advanced technology became, it could not bargain with geometry. This required accepting that human capability, while impressive, was not unlimited. There were places in the possibility space that were simply off limits, not because current technology was inadequate, but because reaching them would violate the logical structure of reality. This was a mature recognition that ambition must be tempered by understanding, that wisdom sometimes means accepting what cannot be changed. By this point, the limit no technology could outrun had revealed its true role. It was not a barrier to innovation. It was a framework that made innovation meaningful. Without it, the coherent universe within which technology operates would dissolve into chaos. The limit provided the stable foundation upon which all progress was built. Far from being an enemy of advancement, it was a precondition for it. And once that was understood, the question was no longer how to escape the limit. It was how much of reality depended on it staying exactly where it is. The answer, it turned out, was everything. Every stable structure, every coherent process, every meaningful achievement depended on the speed limit remaining immutable. Remove it, and reality itself would unravel. The climax of this story is a reversal of expectation. The limit no technology can outrun is not an obstacle placed in our way. It is a condition that allows the universe to function at all. This inversion transforms frustration into appreciation, resistance into gratitude. What seemed like nature's refusal to cooperate was actually nature's way of maintaining coherence. The speed limit was not a ceiling on possibility, but a foundation for reality. Once this is understood, the speed limit stops feeling restrictive. It becomes protective. By capping how fast information and influence can travel, the universe preserves order. Causes come before effects. Events unfold in sequence. Reality remains intelligible. Without this protection, the orderly procession of moments would collapse into temporal chaos. The reliable connection between action and consequence would break down. The universe would become fundamentally unpredictable, not because of complexity or randomness, but because of logical inconsistency. The speed limit prevents this dissolution, keeping reality stable and comprehensible. This insight reshaped physics and engineering alike. Instead of chasing impossible speeds, progress shifted toward efficiency, precision, and structure. Communication learned to work with delay. Exploration learned to navigate vast distances without shortcuts. Technology adapted to the universe, rather than demanding the universe adapt to it. Engineers stopped asking how to break the limit and started asking how to work optimally within it. This shift was not defeatist but realistic, not limiting but liberating. By accepting the constraint, innovation could focus on what was actually possible, achieving remarkable advances in areas where the speed limit was not an obstacle. Satellites, particle accelerators, nuclear power, and countless other technologies succeeded by respecting rather than fighting fundamental limits. More deeply, it reshaped perspective. Not every limit is a failure to overcome. Some limits are foundations. Remove them, and the entire structure collapses. The universe does not offer infinite freedom. It offers coherent freedom, bounded by rules that keep it stable. This principle extends beyond physics. In any complex system, constraints often enable rather than prevent functionality. Limits define possibility spaces, channel creativity, and prevent chaos. The speed limit exemplifies this principle at the most fundamental level, a boundary that, far from stifling the universe, gives it the structure necessary to exist at all. Today, this limit quietly governs everything from particle accelerators to cosmic evolution. It shapes how stars burn, how galaxies form, and how time itself flows. No invention has ever crossed it. None ever will. The speed limit is woven into every process, every interaction, every moment of cosmic history. It determines how quickly information can spread through space, how rapidly change can propagate, how fast influence can travel. These constraints shape the universe's large-scale structure and evolution, making the cosmos we inhabit possible. And perhaps that is the most important lesson. Progress does not always mean breaking boundaries. Sometimes it means understanding why a boundary exists and what it makes possible. Maturity involves recognizing which limits to push against and which to accept. The speed limit belongs to the latter category, not because it is too difficult to overcome, but because overcoming it is conceptually incoherent. Understanding this distinction represents a kind of wisdom, an ability to work with reality as it is rather than demanding it be different. The limit no technology can outrun is not the end of ambition. It is the reason ambition can exist without tearing reality apart. By providing a stable framework within which progress occurs, the speed limit enables rather than prevents achievement. It is the guardrail that keeps the universe on track, the boundary that defines coherence, the foundation upon which everything else is built, far from being an obstacle to overcome. It is a gift to be appreciated, the constraint that makes everything possible. The limit